Okay, students, now this video I'm going to show you the second derivative test. Alright, the question y equals to negative x cubed plus 3x is exactly the same function that we have used previously for the first derivative test. So the question remains the same. We are tasked to find the coordinates of the stationary points and determine its nature. So therefore, same steps, dy dx. We differentiate it once, so we have negative 3x squared plus 3. But now, since we are at the using the second derivative test, okay, we shall differentiate one more time. So differentiate it one more time. So our d2y over dx squared, our second derivative. So differentiate it once more time. So end up with negative 6x. Right. So same thing, we're going to find the coordinates. So for the coordinates, as usual, at the stationary point, what's so special? Our dy dx is always equals to 0. So therefore, negative 3x squared plus 3 equals to 0. X squared minus 1 equals to 0. We still have x minus 1, x plus 1. So x equals to 1 or x equals to negative 1. Since the question wants to have x greater than 0, x equals to negative 1, we're going to reject it. And we want to find the coordinates. So when x equals to 1, y will equals to negative 1 plus 3. Alright, so the coordinates is actually 1, 2. Now, to determine its nature, we're going to use the second derivative test. So let me use this table here to explain to us. Now, for dy dx, okay, at stationary point, dy dx, be it minimum, maximum, or is it undefined? Sometimes undefined remains to our point of inflection. The dy dx is always 0, 0, 0. Now, what about our d2y dx squared? It's something different really. When the d2y dx squared is positive, it tells us that it is a minimum point. When d2y dx squared is negative, it tells us that it is a maximum point. Now, the tricky part comes in when d2y dx squared, it gives us a 0. It tells us that it is undefined. So when 0, when we apply the second derivative test, d2y dx squared gives us 0. That means we cannot define whether it's maximum, minimum, or a point of inflection. Okay, most likely it will not be a maximum minimum point. It will be a point of inflection. But point of inflection, there are two types. Okay, one that look like this or one that look like this. So which is which? So we don't know. So when it's undefined, we will need to go back to our first derivative test, okay, to determine the shape of the graph. Now, so with that understood, with this, so let us look at how to solve for it. Okay, so now our d2y over dx squared equals to negative 6x. So we know when x equals to 1, my d2y dx squared is actually negative 6. So therefore, d2y dx squared is negative 6. So negative tells us that it's a maximum point. So therefore, it is a maximum